Hi everyone, today we're going to learn about how to write numbers in scientific notation. Scientific notation is an alternate form of writing numbers that is different from standard notation. It's most useful for writing extremely large or extremely small numbers in a more manageable form. It makes use of powers of 10 or 10 raised to an exponent. So let's look at the number that we're going to use to help guide our rules for how we write a number in scientific notation. This number shown here is approximately equal to the number of particles in 1 mole of a substance. You'll see this number many times throughout the year. Express this number in scientific notation. First rule for scientific notation, we're going to be moving the decimal place from its current location in the standard form, after the last zero, to a new location. In this case, the rule is that there is 1 digit to the left of the new decimal place. So for our guiding example, that means the new placement for the decimal will be between the 6 and that sandwich 0 that is between the 6 and the first 2. So next. The second rule is only significant figures get included in the new form. Specifically, they're only ones included in what we call the mantissa. They're all the numbers that precede the power of 10. So in the number that we are using, the only significant figures are the 6, the sandwich 0, and both of the 2's. So this initial first part, the mantissa, will be 6.022. Now we're moving on to the part that follows, which is to do times 10 raised to a power. There are 2 aspects of that power of 10, the magnitude or size and its sign. The magnitude or size of that power of 10 is related to how many times the decimal place must move in order to go from its place in the original standard notation to its new location. So for our guiding example, the original decimal place is after that final 0 and it's currently unspoken, and it moves to between the 6 and the sandwich 0. In order to do so, it must move 23 times. So the magnitude for our power of 10 will be 23. We now need to determine whether it is a positive 23 or a negative 23. The sign for the power of 10 depends on whether the decimal needed to be moved to the right or the left to get to its new location in the scientific notation form. Positive powers in 10 are used for large numbers. So in this case, if the decimal is moved to the left, as it would for a large number, then it has a positive power of 10. Negative powers of 10 are for small numbers. The decimal moves to the right for these. So in our guiding example, the decimal must move to the left because this is quite a large number, which means our power of 10 will be positive. So our final answer for this is that this number is equal to 6.022, our mantissa, times 10 raised to the 23rd power. Notice that because it's positive, I don't have to write a positive sign to say that. It is implied by the lack of negative sign. So let's look at a few more examples. Pause this video and take some time to try to work out what these might be. The answers for the numbers. 755 million would become 7.55 times 10 to the 8th power. There must be only one number to the left of the decimal, in this case the 7, followed by the other significant figures, 2 5's. And in order to move from the unspoken decimal on the far right of this number to its new place between the 7 and the first 5, you must move 8 times. So that is why it is 7.55 times 10 to the 8th. For the second one, we are moving to the right, so this is going to be a negative exponent. It must move 4 times in order to get to its new position between the 7 and the 5. So the number is 7.56 times 10 to the negative 4th. For our third example, we must move to the left, so it will be a positive power of 10. It must move 11 times in order to get from its unspoken position on the far right over to between the 8 and the 4. And then we need to write the mantissa. So it becomes 8.405 times 10 to the 11th power. In our fourth example, this is a very small number, so we will have a negative exponent once again. In order to move the decimal from where it is to between the 2 and the 3, we must move it 9 times. And so the number is 2.3540 times 10 to the negative 9th power. Our next example, 525,600, which is the number of minutes in a year, is equal to 5.256 times 10 to the 5th power. It is a large number, so it must be a positive exponent, and it has to move 5 times to get to its new position for the decimal. Our second to last example is a very, very small number, so it's going to have a negative exponent. In order to move it between the two 5s, I have to move it 18 times, and so the number becomes 5.500 times 10 to the negative 18th. And our final one, I could not find the actual spelling for this, but a googol is a 1 followed by 100 zeros. And if I wanted to write a googol with 3 significant figures, it would become 1.00 times 10 to the 100th power. Good luck on your practice problems.